recording again. Hopefully it records and doesn't have any issues. That way later, if you're working on your lab report, when you're working on this lab and you forget something I said, you can go back and watch the video. Let's see here. Recording. Share the screen. And let's do attendance. So just, I'm going to do attendance the way I usually do for lab, which is where I call your name. I'm also going to tell you which group you're in. We're going to do things a little bit different than last time, or than the other time. So this time, no matter whether you did your pre-lab or not, you're going to be in a group that's actually doing something. But if you didn't do your pre-lab, you just need to watch and observe and, try not to get in the way. So that being said, Brumfeld, not here. Champion, you're in group 5. Gorby, not here. Gross, you're in group 1. Gunther, group 2. Reading ahead there. Hill, you're in group 3. Other Hill is absent. Jackson, group 4. Keys is not here. Perez, group 5. Sigmund, group 1. Slaughter, not here. Smith, group 2. I know Smith here in general. Okay. Smith is group 2. Stover, group 3. Tompkins, group 4. Van Nest, group 5. Watson, group 1. Young, group 2. Zweiback, back there somewhere, right? Yep. Zweiback, you are group 3. Lawrence, oh, there you go, group 4. Wilson, you are group 5. So once we're done with a quick pre-lab lecture, group 1 will be here, group 2 will be here, group 3 will be here, group 4 will be here, and 5 will be here. So really quickly, let's get this pre-lab lecture done so you guys can get started. All right. So it's too late to do the pre-lab, so I don't mind just giving you the answers here. Let's take a look. Okay, and I'm going to go through this very quickly. In these experiments, respiration causes a decrease in pH. How does this happen? You need to know this, obviously, because you had to answer it. And when you write your lab report for your introduction, depending on how well you wrote this, you might be able to just copy it and paste it. Because remember, in the introduction of your lab report, you need to discuss how the pH works. So in this case, with respiration, right? Respiration produces carbon dioxide. Carbon dioxide mixes with water to produce carbonic acid. And I don't even care that you remember that it's carbonic acid, just it produces a type of acid. Obviously, as pH goes down, that's when things become acidic. So as things become acidic, because you're adding carbon dioxide to it, the pH goes down. Any questions about that? All right, how does the opposite happen? How does it go up when it's photosynthesis? And all this is written on the wall to remind you, photosynthesis up, respiration down. In this case, photosynthesis is using carbon dioxide. Therefore, it's taking carbon dioxide out of the water. Therefore, you're having less of it mixed with water to produce an acid. Therefore, it's getting less acidic and the pH is going up. Any questions about that? All right, this is a really basic one too. This goes back to the first law of thermodynamics that you learned in the previous chapter. Does photosynthesis create energy or does it convert solar energy to chemical energy? Really, I think everyone who did it got it right because it's very simple. It's just more like it's repetitive to drill it in your head because you're going to write about that in the lab report as well. Photosynthesis converts solar energy to chemical energy, right? It does not create energy. You can't create or destroy energy. It's only converting it from one form to another. Any questions about that? Okay, choose a correct statement, A or B. I talked about this in the pre-lab lecture, and don't make this mistake when you're writing a lab report. Again, this is all geared towards helping you write your lab report. In these experiments, we are trying to determine if different conditions affect the pH of a solution. That's A. Or statement B, in these experiments, we're using the pH of solution to determine if different conditions affect the rate of photosynthesis or respiration. And B is the correct answer. This is not an experiment about pH. pH is simply what we're using to measure the rate of photosynthesis and respiration. This is not a pH experiment. pH is just a tool that we're using. So any questions about that? All right, and again, this is redundant, but I want to make sure everybody knows what they're doing. This is going to help you with your lab report. Look at the chemical equations in the introduction. If we could somehow measure the amounts of oxygen, what would it mean if the levels of oxygen were increasing? Without pulling up the equation, just think about it, right? Photosynthesis produces oxygen. So if oxygen is increasing, photosynthesis is happening, right? Likewise, for question 10, what would it mean if levels of glucose were increasing? Again, photosynthesis produces glucose, so if you have more glucose, that must mean photosynthesis is happening. That's it. Any questions about that? Okay, before we jump into it, I want to talk about a few things and remind you of a few things. So these are the tables you're going to fill out, and I'm going to ask you, unlike what you guys usually do, please fill these out as you're getting the data. Don't wait until you're done and put it in there, because this reminds me of a second thing that I want to remind you. Even though you're only going to write a lab report about the one lab you did, you still have to do the entire lab worksheet, right? So you need to be seeing this data happening in real time. That way, hopefully, you can catch any red flags. Or if you see something that you want to question, you can go to that group and say, hey, what happened? Is that right? You know, what's going on with this pH? Because you are responsible for that. Remember, you are responsible for the data. You need to look for red flags. So please, as you guys are doing this, fill this out as you get your data. Notice too, at the bottom, if you look at your lab worksheet, it'll say total. But here, it doesn't say total. I want you to calculate your own total, the total change, and it's pretty simple. Total change is your final pH minus your initial. So for example, if you started at 9, and then whoops, that would be better if we showed it that way. Anyway, if you started with 9, ended with 9, right, final 9, but you started with 7, right? So if you went from 7 to 9, that would be a change of positive 2, right? If you started at 8 and ended with 5, so the formula would be 5 minus 8, then you would have a negative 3, and this is where people usually mess it up. And just use common sense. After you've done the math, just use common sense. If you started at a smaller number and went to a larger number, it should be a positive number. Is your total change, right? If you started at a larger number and ended at a smaller number, that should be a negative change. Right? Everybody make sense? Does that make sense to everybody? And again, those are some examples. What else to tell you before we get started? We might call some audibles. Actually, I'm going to do it right now. So, for your tables, where it says respiration, anything in the dark, we're going to check the pH every 10 minutes. So you'll do it at the beginning, but then you'll skip, then check it again. Skip. Check it again. Skip, and then check it again. And just so you know why I'm doing that, because think about it. What you're going to do is you're going to have these things, these cuvettes, filled with algae beads and a liquid that changes color as the pH changes, and you're going to see what the pH is by using this, like we talked about last week. But the ones doing respiration are going to be wrapped in aluminum foil, and they're going to be in the dark. Now, to see what color their pH is, what color they are, what pH they are, you have to unwrap them and compare them to the color guide, right? So what happens when you unwrap them? That's problematic. These things are in respiration, so when you unfold them to look at them, what is problematic about that? I'll reword it. They're in the dark for the experiment, but to check their data, to check their pH, you have to take them out in the dark. That's the issue, right? So every time you take it out to look at it, you're exposing it to light. So in a perfect world, we could somehow do those measurements in the dark, but you have to take them out of the aluminum foil to see them, which means they have to be in the light. So that's why we're doing that. Really quickly, temperature, photosynthesis, respiration. Okay. So on your labs worksheets, you should have what we have up here, which is the X's. X's just indicates no measurements were taken at that time. All right, and the last thing I'll say before I cut you guys loose and before I start walking around to help you get set up is throughout this experiment, this lab, I'm going to be talking about stuff, so please try to pay attention to what I say. I'm going to give you hints All right, we're going to talk about how this data is changing. I'm going to be looking at some of the questions on your lab and basically telling you how to answer them. So make sure you're paying attention. That way when you're doing your lab, like, oh yeah, I remember him talking about that. So I'm going to write that. So any questions before we get started? All right, everybody get to your groups, and he and I will go around and get you guys started. If you want to bring the ice here and there, please. Group 5, you're going to be over here. But I'm going to leave these here for now, and I'll explain how everything happens. There we go. All right, so group 1, you guys ready? Let's get you guys started. So very simple. You're going to have one in the dark, different light intensities. And it says what? On every 10, 20, 30 centimeters. So really, you know what? Let's change that to 0. I'm going to call it 0, even though it's not technically 0, because it's going to be directly under it. So I have 1 under it. Let's see. And then when the time comes, you'll have 1 at 10. Now let's do it like this from the edge of the light. So 1 at 10, 1 at 20, right there we go, 10, 1 at 20, and 1 at 30. When the time comes, right? Which is about to come. So